The scope of this course is only limited to punching and blanking operation of sheet metal. However, these two operations are the most prominent one and is used mostly in major industries. Now in punching and blanking operation, a ram and die is used to induce shear stresses in the material. And the material here is our sheet metal. If the shear stress becomes greater than ultimate shear strength of the workpiece material, then the cracks will be formed at 4 points A, B, C and D, as you can see here. If the cracks meet at the center, then some material gets removed, leaving behind a hole on the workpiece. The material removed is called as blank, and if the entire operation was performed to obtain the blank, then we call it a blanking operation. And if the entire operation is performed to generate a hole, then we call it a punching operation or a piercing operation. So we can say, if hole is the outcome, if hole is the desired outcome, the sheet metal operation will be termed as punching, and if blank is the desired outcome, then we will term this operation as blanking. Now, for punching and blanking operation to take place, the punch size must always be less than the die size. Hence, there has to be some clearance between the punch and the die. If the clearance is too small, the 4 cracks formed at points A, B, C and D will not meet at the center, and we will not get the desired shape of the blank and of the hole. And if the clearance is very large, the workpiece will simply enter the die and bending of workpiece will take place, and hence no material will be removed. So for this particular reason, there must be an optimum clearance for the operation to take place, and this optimum clearance is given by C is equal to 0.0032 T under root tau S. Here T is the thickness of the sheet metal and tau suffix S is the ultimate shear strength of the material, which is generally calculated in megapascals. The clearance here, the clearance in the question here is by default radial clearance. Some of the clearance value of different type of material are given here. For brass, we have 5% of material thickness. For mild steel, it is 6%. For hard steel, it is 7%. And for aluminium, it's 10%.